Within a boundary layer, for a steady incompressible flow, the Bernoulli equation, so we need to choose among these four options: holds because the flow is steady, holds because the flow is incompressible, holds because the flow is transitional, and option D, does not hold because the flow is frictional. So we know the Bernoulli's theorem. Bernoulli's equation, it can be represented in head form as P by rho G plus the pressure head, the velocity head, V square by 2G plus Z is equal to constant, without considering the losses. We are just writing the simple Bernoulli equation. This Bernoulli equation can be derived from the Navier-Stokes equation with certain assumptions, and the assumptions in the Navier-Stokes equation to derive the Bernoulli equation is that the fluid is ideal. So let's write number 1, the fluid is ideal. Okay, number 2, the flow is steady. Okay, flow is continuous, obviously. Number 3, let's write incompressible. Okay, so flow must remain incompressible. Del dot V should be equal to 0. Here dou by dou T of V should be equal to 0. The ideal, it should follow the ideal gas equation, that is PV is equal to MRT. Okay, these are the assumptions. Other than this, the flow is irrotational. Number 4, irrotational flow. That means the curl of the velocity will be 0 and flow is always along the streamline. Okay, and if the fluid is ideal, that means it is inviscid. Okay, so the fluid is inviscid, or we can write inviscid flow. Okay, so this is also the assumption of Bernoulli's equation. All right, now in case of boundary layer theory, see the formation of boundary layer occurs because of the friction. Now, suppose this is a flat plate, or we can also take the example of pipe. There will be formation of layers over this flat plate. Why? Because there is friction between the fluid. Okay, that means we are considering that the flow is viscid, for viscid flow or viscous flow. Okay, that means friction is not 0 here. Okay, the friction, or we can say the viscosity, is not 0 here. So viscosity of the fluid, the dynamic viscosity, is not equal to 0. So that's the essence of the boundary layer theory. So from here we can say that option D does not hold because the flow is frictional. So for boundary layer, the Bernoulli equation doesn't hold because the flow is considered to be frictional. So option D is the correct choice. For more information, you can refer to the NPTEL course lecture number 24, Introduction to Boundary Layer Theory on Advanced Concepts in Fluid Mechanics by Professor S. Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.